If you're in cybersecurity, you know the feeling. You're just drowning in a sea of alerts, day in and day out. Well, today, we're going to talk about Splunk Enterprise Security, a platform that's basically designed to be a life raft in that storm. We're going to see how it takes all that chaotic data and turns it into something clear, something you can actually act on. Let's dive in.
So, just imagine for a second. Your security team is getting hit with alerts all day, every day. But what if instead of chasing down thousands of little disconnected breadcrumbs, you could actually see the whole picture? What if you could take all of that noise and boil it down to one single high-confidence threat that tells you the complete story? Well, that's the big promise we're going to unpack.
All right, before we get to the solution, you really have to appreciate the problem. For any modern security operations center, a SOC, the reality is just this relentless, nonstop storm of alerts. It's a constant battle just to keep your head above water.
And look at where it all comes from. You've got data pouring in from your firewalls, your endpoint tools, your cloud services, Active Directory, the list goes on and on. Now, each one of these tools is doing its job, right? But together, they just create this deafening noise of individual events that, honestly, don't have a lot of context on their own.
And you know what happens when you have that constant flood of information? You get something very real and very dangerous called alert fatigue. I mean, think about it. When your analysts are staring at hundreds, maybe thousands of potential incidents, there's just no way they can investigate every single one. And that's the scary part, because it means the really critical threats, the ones that can actually do damage, can get completely lost in the shuffle. And that's exactly where something like Splunk Enterprise Security, or ES, comes into the picture. It's a solution built right on top of the Splunk platform, and it's designed specifically to bring some order to all this chaos. Think of it as a really smart CM that gives you the analytics and the response tools you need to finally fight back against that alert fatigue.
Okay, so theory is great, but how does this thing actually work in the real world? Let's walk through a little story, a hypothetical security incident. We're going to follow the breadcrumbs from just one tiny, easily missed event all the way to a fully contained threat.
So our story starts with a single log entry. Just one out of millions. A user logs into the network, but the login comes from a place that's, well, pretty weird for them. Now, by itself, this isn't a smoking gun, right? It could be someone on vacation. A busy analyst might see it, think, low priority, and just move on, completely missing the very first clue of an attack.
But here is where things start to get really smart. Splunk ES doesn't just see an isolated data point. It takes that single event and immediately starts building a case around it, like a detective. It knows this could be the start of a story, and it begins to add that all-important context.
First up, it uses what's called the Assets and Identity Framework. This is all about business context. Instead of just seeing a random username, ES asks, okay, who is this person? What's their job? What machine are they on? And is that machine important? All of a sudden, that vague login isn't so vague anymore. It's now tied to, say, the CFO's laptop. And that changes everything.
And it doesn't stop there. Next, ES runs that event through the Threat Intelligence Framework. This is where it checks that data against massive, constantly updated lists of known bad guys online, malicious IP addresses, shady domains, you name it. So it's asking, is this weird location just unusual, or is it a known server that attackers use?
And boom, look at the transformation. What started as a simple, boring login from IP 1.2.3.4 is now something totally different. We now know it's the CFO, and they're logging in from an IP address known to be malicious. This isn't just a minor blip on the radar anymore. This is a serious red flag.
This is where the story really gets powerful, because Splunk ES isn't just looking at that one event in isolation. It's now actively hunting for any other sketchy behavior tied to that same user or that same laptop, connecting all the dots to show you the full story. Now, the engine that drives this is a concept called risk-based alerting, or RBA. And this is a huge shift in thinking. Instead of just creating a separate alert for every little thing that happens, RBA groups them all together. It assigns a risk score to each activity and then adds them up over time for that specific user or device.
So think about it this way. After that weird login, maybe some malware gets detected on the CFO's laptop. A few minutes later, someone plugs in an unapproved USB drive. In the old world, that's 3 separate, low-priority alerts. Your analyst has to find all 3 and piece the story together themselves. But with RBA, nope, they're automatically combined into one single high-risk alert.
Yeah, and you can see how it works. That unusual login, maybe it adds 20 points to the risk score. Not a huge deal. But then the malware detection adds another 35 points. Now we're at 55. Then the USB drive adds 30 more. Suddenly, that user's risk score is at 85. And once it crosses a certain line, ESM raises its hand and says, "Hey, pay attention, something serious is going down over here."
Okay, so now we have a genuine high-confidence threat with all the context we need. This is where ES shifts gears from just detecting stuff to actually responding. And the best part is, that response can be totally automated to stop an attack dead in its tracks.
This all happens through what's called the Adaptive Response Framework. You can think of it as the conductor of your security orchestra. It lets Splunk ES talk to all your other security tools, your firewall, your endpoint protection, anything, and tell them to take immediate action.
So for our CFO, an automated workflow just kicks into gear. Within seconds, literally seconds, the system tells the firewall to block that malicious IP, it tells Active Directory to disable the user's account, it creates a ticket for the incident, and it sends a notification to the SOC team. All of it happens automatically. The threat is contained before a human even has to touch a keyboard.
All right, so we've seen what it does, but how does it actually pull all this off? Let's pop the hood real quick and look at the key technologies that make this whole thing possible.
The absolute secret sauce to all of this is something called the Common Information Model, or SIM. The best way to think of it is as a universal translator for all your security data. You see, every tool has a different name for the same thing. One firewall log might call a source IP src_IP, while another calls it source_address. SIM fixes that. It standardizes everything.
And right here, you can see exactly why that is so critical. By mapping all these different names to one single common field name like SRC, SIM lets you run one search that covers data from your firewall, your proxy, and your web server all at the same time. It's the magic that makes true correlation possible. And finally, where do all these smart detections come from? They're not just pulled out of thin air. The whole system is powered by a massive and constantly growing library of security knowledge. Things like Splunk Security Essentials and the ES Content Updates deliver over 900 pre-built detections and are always being updated with the latest threat intelligence. It's the backbone of the whole system.
So, when you bring it all together, you can see the real value here. Splunk ES fundamentally changes the game. It takes a security team out of that constant, reactive firefight of chasing individual alerts and turns them into a proactive, context-driven threat hunting team that actually understands the full story of an attack.
And that really just leaves us with one final question to think about for your own operations. Is your team spending all its time reacting to noise, or are they truly empowered to respond to real, actual threats?